Welcome IED students to a quick video about converting units. I'll use the first example to just explain the concept of what we're doing, and then there's just a few more examples to make them one to use metric, and then the last one will be a little bit more difficult. Okay, first off, what is converting units? Converting units is simply to express the equivalent of a measurement, so something that's equal in measure, but in terms of a different unit. Okay, and so the first example says to convert 8 inches into feet. Now what we're going to do for all of these problems is use a conversion factor. And a conversion factor is something that we multiply by. So factors, think of in math class you're asked to make a factor tree, like what are the factors of 12, like 2 and 6. So if I use the word factor, just think things that multiply together. Okay? So the method here is going to be to use a conversion factor. And a conversion factor, I'm going to rewrite 8 inches times. In this case, our conversion factor is going to be a ratio, a fraction. And it is going to have the two units that are at play, the one we currently have and the one we want. So we have inches and feet. And that conversion factor is going to house an equivalency statement. How many inches equals how many feet? Now this is a well-known equivalency. I know we're trying to figure out how many feet 8 inches is, but we need to go back to just kind of our more simple known equivalency. For this one, for example, we know that 1 foot is equal to 12 inches. We're going to use that known equivalency to help us convert. So these two are going to go into a ratio. And we call this, in this fraction, this ratio is what we're going to multiply 8 inches by. And that'll make our inches go away, and it'll convert it accurately to feet. The unit that you currently have, okay, inches, notice that where it's at in a fraction, if you don't see this as a fraction, anything is itself over 1, it's in the top. Then between these two, I have inches and feet. I need to put the one we currently have diagonal in the conversion factor. So that means on the bottom this time, they're diagonal. The other unit, the one we want, is going to go on top. And then the values follow. So it's 1 foot, 12 inches, and that's a conversion factor. A factor means we're going to multiply. So we're going to multiply 8 inches by this. Now with multiplying fractions, you may recall, I'm going to write this a little tighter, 8 inches times 1 foot over 12 inches, that with multiplying fractions, you are allowed to cross-reduce. Now that is not cross-multiplying, that's something different. Cross-multiplying is when you have a proportion. We don't. Students get that confused. We are multiplying fractions. To multiply fractions, you go straight across, multiply the tops, multiply the bottoms. However, you are allowed to look for common factors that reduce diagonally. And I see a common factor of 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So I'm allowed to do that before I multiply straight across. Similarly, the units can reduce away. And that's how we're going from inches to feet. So the inches diagonal from each other, one on top, one on bottom, can cancel each other out. And so I'm left with 2 times 1 foot. So that's 2 feet. And on the bottom, I'm left with 1 times 3, which is 3. So in the end, I have 2/3 of a foot. As a decimal, I'll round that to 2 decimal places. 2/3 is 0.6 repeating, which to 2 decimal places would be 0.67 feet. Okay? So I took a little extra time on that one just to explain. We're going to multiply our current measurement by a conversion factor. It's a fraction that has the unit you currently have, inches, and the unit you want, feet. These need to be known equivalents, okay, 1 foot and 12 inches. The one we currently had was diagonal, okay, from the original measurement, so that they'll cancel out. And then it's just multiply and simplify. So let's try this one. This one, though, is from our metric system. And I gave you guys, I'm going to show this, So remember, we're looking for meters and kilometers. I had given you this formula sheet that contains this table with all of our prefixes, okay, for the metric system. And how you read this, so we wanted kilometers or kilometers, right, is we find that unit, and how you read this is you say one of this prefix. So 1 kilo equals that number, they're all expressed as a power of 10, of the base unit, so in this case meters. So 1 kilometer equals 10 to the third meters. One of these equals that many of the base. So let's write that down. So it's 1 kilometer equals, it was 10 to the third of the base unit meters. This is the known equivalency that will be used for our conversion factor. So let's write it out. 17,500 meters times our conversion factor. Between the two units, the one I currently have is currently in the numerator. So between these two, it's going to go on the denominator. So they're diagonal and will cancel. That means kilometers goes on top. The numbers just follow. The 10 to the third power goes with the meters. The 1 is with the kilometers. And now we're ready to multiply. Okay, the meters are going to cancel. 17,500 times 1 is just 17,500. 1 times 10 cubed is just 10 cubed. What is 10 cubed? Well, 10 times 10 times 10 is 1,000. The units are gone. So really what we end up having is just 17,500 divided by 1,000 kilometers, or 17.5 kilometers. Okay, the next one. Let's look at our table again. Liters and milliliters. I know the table is going to be, I'm looking for this prefix, and it'll be 1 milliliter equals how many of the base. So if you're not familiar with that, let's look. And milli is smaller than the base, so I found it over here, and the number is less than 1. 1 milli equals 10 to the negative 3. So remember that, 10 to the negative 3. Okay, so I'm going to write that in exactly how it was. We'll deal with that negative exponent later. Okay, so let's start writing our problem. We're going to use the conversion factor, 0.0068 liters times a fraction. This is currently not written as a fraction, so it's itself over 1. So the liters over here goes on the bottom so that they're diagonal, which means the ml, milliliters, go on top. Okay, and then the numbers follow suit. So 1 with the ml, 1 ml equals that many of the liters. And I know that's not very nice. Okay, so let's rewrite that right now. I'm not even going to cancel units yet. So it's 0.0068 liters times, so what do we do with this? Last week I explained that a negative exponent means that that base would be on the other side of the fraction with a positive. So that 10 to the negative 3 is really a 10 cubed in the top. Now when you move that to the top, the units, you might have a tendency to want to move them. They do not move, they stay right where they're at. So do not move your units, we're just moving that factor. Well, what does it leave behind? Well, any number is itself times 1, right? So it leaves behind a coefficient of 1, not 0. Okay, the denominator doesn't become 0. It's just we had on the bottom that times 1, so now the 1's left. This factor moves up. And 10 cubed is 1,000, right? So that's 0.0068 liters times, if you wanted to rewrite that as 1,000. So our liters are going to cancel, and we're really multiplying by 1,000, which is going to give you 6.8 milliliters, or mLs. All right, the last one. What makes this one a little more difficult? If you look at the two prefixes, we're dealing with grams. We have decagrams, okay, and we have micrograms. Well, decagrams is bigger than 1, and micrograms is smaller than 1. So if you look at our table, numbers greater than 1 includes deca, does not include micro. Micro is found over here, numbers less than 1. So sometimes students struggle with when they're converting from a unit that was over here to a unit that's over here. So a simple, with a, maybe a half a step longer, but a simple way is to not go straight from deca to micro, but to stop at the base unit on the way. So let's go from deca to the base unit, and then from the base unit to micro. So let's record these real quick though. It's 1 deca equals that many of the base. So you can remember that 10, deca is 10. And then micro, it's 1 micro equals, it's probably hard to see, but that's 10 to the negative 6 of the base. So a micro is 10 to the negative 6. So let's record those real quick. These are our equivalencies that we're going to use. So 1, the abbreviation for deca is DA. So 1 decagram was equal to 10 to the first grams. And then 1 microgram, the abbreviation is this mu, okay, is equal to, it was 10 to the negative 6 grams. Remember, it's one of the prefix equals that power of 10 shown of the base. So we're going to use these. Now let's write it out. 0.000054 decagrams. And all you're going to have to do this time is have 2 conversion factors. Okay, in the first one, we're going to use decagrams and grams. We're going to convert from decagrams to grams. So we've got decagrams on the bottom, so they cancel, and grams on top. The equivalencies, 1 decagram was equal to 10 grams. And then right away, you can just say times another conversion factor. You now have grams, and we'd like to go from grams to micrograms. So now, since grams is on top and we want it to cancel, the grams goes on bottom, and the micrograms goes on top. And then plug in your knowns. 1 microgram equals 10 to the negative 6 grams. The grams are going to cancel, and you will be left with micrograms. So let's write this out. We have 0.00054 times, we have 10 over 1, and then times, oh, look at that negative exponent. That means it's really 10 to the 6th on top, leaving a 1 behind. So we're going to multiply that together and get micrograms. Okay, so you can just do that in 2 steps if you want. That number times 10, and then that answer times 10 to the 6th, or some of you might realize that that's really 10 to the 7th. Okay, and you are going to get 540 micrograms.